Hey everyone, welcome to another session of CeerazzleDazzlePhysics. In today's session, we'll be talking about radioactive dating, guys. So put down today's title, it's going to be radioactive dating. Okay, so before we get started, make sure you like and subscribe to keep my channel going, and make sure that you have watched my other video on the half-life before watching this lesson, because if you don't watch that video, this lesson won't make sense. So make sure you understand the concept of the half-life before watching this video, guys. Okay, so today's big question is the following. How can we use radioactivity to determine how long something has been dead for? How can we use radioactivity to determine how long something has been dead for? Right, you've probably heard in the past that scientists might find something which has died and they're able to calculate how long it's been dead for. Well, the way they do it is actually by using radioactivity, guys. So by using radioactivity, they can work out how long something has been dead for. So the way they do it is the following. Scientists can determine how long something has been dead for by looking at the amount of carbon-14 within it. So scientists, they look for something very particular. It's going to be carbon-14. What is carbon-14? Carbon-14, guys, this is a radioactive isotope, guys. So here it is a radioactive isotope. There we go. So it's a radioactive isotope. And you know that all radioactive isotopes, they will decay as time goes on. So the radioactive isotope will decay. So it will decay. So scientists look at the amount of carbon-14 in the organism that has died. So scientists will look at the amount of carbon-14. So you're probably a bit confused. You're probably thinking, well, where does this carbon-14 come from? Well, I'll explain it with the following diagram. Right, so here, guys, I've got an alive stage and a dead stage. So right now, this is, let's say this is a person, and obviously carbon-14 is usually taken in from the food that we eat. So carbon-14 is constantly going into the actual person. So over here right now, this person's taking in carbon-14. There we go, carbon-14 from everywhere. It goes inside the person right now. So if you're alive, you're constantly taking in. So the carbon-14, let's say it builds up within you. So this little block here represents the carbon-14. But for example, let's say, God forbid, this person dies. What will happen is that carbon-14 that was there, so the carbon-14 should be this amount right now. But obviously, you know it's radioactive. So look, what's happened to it from there to there? Obviously, as you can see, the object has died, so therefore the amount of carbon-14 has decayed. So carbon-14 has decayed. So the carbon-14 is less than what we had before. So at the start, obviously, you're alive, you're constantly having carbon-14 going into you, so you have a constant value. But obviously, if dead, what happens is the amount of carbon-14 decreases. The amount of carbon-14 decreases. Hopefully that makes sense. When you're alive, the carbon-14 obviously is inside you, and obviously it's constant because you're constantly getting carbon-14. But if the organism dies, what happens is the amount of carbon-14 will decrease. So the amount of carbon-14 is now less than before. Okay, so you're probably thinking, well, that still doesn't kind of give me any value. How long has that object been dead for? How are we going to calculate it? So obviously we're looking for the time here. So now we're going to incorporate what we learned about the half-life into this lesson. So if you've forgotten what the half-life is the following. The half-life is the time taken for the number of nuclei in a sample to decrease to half of its initial amount. The half-life is the time taken for the number of nuclei in a sample to decrease to half the initial amount. And for carbon-14, guys, we're going to give you right now. So carbon-14, everyone, carbon-14, its half-life is going to be 5,700 years. So carbon-14, the half-life is 5,700 years. We're going to use this when we're doing our calculations in a moment, guys. So for now, let's take that. The half-life of carbon-14 is 5,700 years. So now let's use it to determine how long something has been dead for. Right, the best way to look at it is obviously by doing a question, and here is the question we're going to be looking at right now. Example 1. The half-life of carbon-14 is 5,700 years. There we go, over here. If a fossil bone has a count of 25, and a piece of the bone from a living body has a count of 200, how old is the fossil? Once again, if the fossil bone has a count of 25 and a piece of bone from a living body has a count of 200, how old is the fossil? Okay, so as you can see, I've drawn an alive stage and a dead stage here. And we're going to add some numbers here to help identify what's going on. So the alive stage right now, so how much should the count be if you're alive? Well, reading the question, we know that you should have 200 of carbon-14 at the start, so carbon-14 should be 200. But dead, you've got 25. So dead, you've got 25 carbon-14. Everyone happy? That's the first thing. I looked at the question, I put down the information onto either side here. Now, the next thing to do is to work out how long it's been dead for. Well, we can use the half-life to do this. So look carefully. After 5,700 years, we know that we're going to have half of the original. So after 5,700 years, we know that we will have half of the original amount. So let's say we start with 200. After the first half-life, so let's say after the first half-life has passed, so 5,700 years have passed, you're going to be ending up with, obviously, 100. There we go. We end up with 100 over here. Okay, right, nearly there. So now we're at 100. What happens if another 5,700 years pass? 5,700 years pass? Well, obviously, we'll end up with half of the original because obviously the half-life obviously decreases it by half the amount. So we end up with 50 over here. Then, obviously, we're trying to get to 25, so therefore, it must be another half-life, 5,700 years. So there we go. We can see that 3 half-lives have passed. So 3 half-lives have passed. What is the total time that must have passed? Well, obviously, it's going to be 5,700 plus 5,700 plus 5,700, which will be 17,100 years old. So that dead fossil over here is obviously 17,100 years old. And did you see how I worked that out? Obviously, I started off with looking at the alive and looking at the dead and working out how many half-lives have passed. I've taught so many kids this concept. I've always said the same method. Do the alive and do the dead and then work out how many half-lives have passed. Don't skip any steps, guys, and draw the diagram if you think that it helps you with your understanding. Wonderful stuff. Right, let's test our understanding with another question. What about this question? The half-life of a radioactive isotope is 27 years. How long will its mass take to fall from 2 grams to 0.25 grams? Okay, so looking at how much we had at the start compared to how much we had at the end, we've got 2 grams at the start. After the first half-life, we'll end up with how much? Half of 2, we're going to have 1 gram. Okay, first half-life. Second half-life is going to be, we're going to get to 0.5 grams. And obviously, it takes me 27 years to drop down. So 27 years for it to drop from 2 grams to 1. It takes me another 27 years to drop from 1 gram to 0.5 because that's the half-life. It takes me another 27 years for it to drop down from 0.5 to 0.25 grams. So logically, what is the total time that has passed? Well, it's going to be 27 times by 3. 81 years have passed, guys. So 81 years have now passed. And there we go. We've done another question, guys, which is a little bit tricky, but we managed to solve it for you guys. Wonderful stuff. Okay, one more question to test our understanding. Okay, so last question, guys. An isotope has a half-life of 30 years. Estimate how long it would take for the number of nuclei to decay to 250 if the starting number is 8,000. So once again, I've done the before stage and the after stage. The initial stage is 8,000, the after stage is 250. After the first half-life, first of all, we drop down from 8,000 to 4,000. That's the first half-life, how much I'm going to be left with. Then the next half-life, half of 4,000, I end up with 2,000. Good. And the next half-life from there, we're going to drop from 2,000, it will be 1,000. 1,000. And then from 1,000, guys, we're going to drop it down even more. The next half-life, guys, is going to be 500. And last of all, the last half-life goes from 500 to 250. There we go. So now, last of all, how many half-lives have passed? Well, you know it's 30 years for each half-life. So 30, 30, 30, 30, and 30. So the total time it's been dead is going to be 1, 2, 3, 4, 5. 5 times 30, it's going to be 150 years, guys, because obviously it's 1, 2, 3, 4, 5 half-lives have passed. Each is 30 years. That's the reason why it is 150 years. Wonderful stuff. Okay, so we're done for another session today. Let's have a quick recap right from the top. So scrolling up right from the top, today's title was radioactive dating. Then scrolling down, I said that make sure that you've watched my previous video on the half-life before looking at it. Then I said to you, how can we use radioactivity to determine how long something has been dead for? Well, we can use carbon-14. We can look at the amount of carbon-14 within an organism. Carbon-14 is a radioactive isotope and it would decay if, obviously, you're no longer alive. Then, scrolling down, I drew an alive stage and after stage. So when you're alive, you're constantly having carbon-14 put into your body. But obviously, if the organism is dead, the amount of carbon-14 will be lower. Why? Because it's radioactive and obviously it would decay. Then I gave a quick recap on the half-life. The half-life is the time taken for the number of nuclei in a sample to decrease to half of its initial amount. And we said that the carbon-14 half-life is 5,700 years. You'll be given the values in the exam. Scrolling down, we then looked at an example. This example, I said that if you are alive, you had 200, and you find something which has died and it's got 25, how long has it been dead for? Well, look, we took the 200, we calculated how many half-lives must have passed for it to get to 25. And obviously, 3 half-lives passed, therefore it was 17,100 years. Scrolling down, I did another example. We went from 2 grams to 0.25 grams. It was another 3 half-lives, but this time each half-life was 27 years, therefore 81 years have passed in total. Final question of the day, we looked at another example. We had 8,000 at the start and 250 at the end. Then we calculated how many half-lives have passed. This one was 1, 2, 3, 4, 5 half-lives have passed. Each half-life is worth 30 years, therefore 150 years in total. And that's it for another session of CeerazzleDazzlePhysics. Make sure you like and subscribe to keep my channel going. I shall see you next time for more cool physics. Make sure you hit the notifications button to keep my channel going as well. Ciao, ciao, and goodbye.